Good evening, everyone. All right, so today we are going to start with our next session, which is on hash table, right? So very interesting one again. And first thing comes first, which is I'm going to share my screen and then we'll start to do the questions. So just give me a moment and then we'll start. All right. So this is the sheet that we have to cover today, and I'm going to share the screen as well. So here I have shared it. All right. So I think that it is visible. Now, the concept that we have to learn today is problems on hash table, right? So we are going to learn that how to basically use hash tables, how to use hash maps and these kind of things today, right? So I'm going to start from the explanation part first of all. So see guys, the first thing is that what is this hash map actually? We want to see to it because yesterday also we were using it, right? So it is quite important for us to know that how this hash map basically works, right? And when we cover collection framework, then we will see it in more detail. So now basically in hash map, what happens is, so today we have to learn about hash map. Right, so hash map is just like a container, right? So if you want to picturize this whole thing, then hash map is just like a container in which entry object resides, right? So if somebody would ask you that what is inside this hash map, so inside hash map, there is another class which is called as entry class whose objects exist, right? So this is a object of type hash map, and then this hash map is going to contain objects of type entry, right? And then this entry is basically having this property where you have to decide that what is going to be the key of this entry and what is going to be the value of this entry. So that's why you need to give us the type of this entry as well. That is what is going to be the key type and what is going to be the value type, right? So it is basically like a capsule, you can say, which is going inside this hash map, which is having two parts. One is key and one is value. And every time you're going to insert a new entry, you have to give these two values to it. One key, one value, one key, one value, one key, one value. Right? So this is how hash maps are built, right? Now we want to see it in practice that what is exactly happening. So the first thing is that because first of all, we need this container in which we can keep our entry object. So the very first thing would be if we want to learn about hash map. So let us create this one. So hash map test. So this is our new class. And inside this class, we're saying that see, we want a hash map object, है ना? Because we want to create an hash map. So we want a hash map object. So we are creating a reference of this hash map type. Now we are saying that, all right, so what is going to be the key and value type that you need to give here? We're saying that, okay, the type of key is integer and the type of value is also integer, right? And what is the name of that container? So the name of container is suppose map. So this time we are defining this external entity in which we are going to keep in future we are going to keep these entry objects, right? So right now we are just defining these containers. So so hash map is equals to new hash map. This is how we have defined the container. And the container itself is saying that the entry object that you're going to keep inside this hash map will have key of type integer and will have value of type integer as well. All right. And then if you want to add something into this hash map, so you have these functions which you can use. So the first function is put function. So put function basically says that what is the key type? Can you give me that? So we are saying that the type of key is integer. So it is suppose 1. And what is the type of value? So that also you need to give some integer value. So that is, we're giving it as 23 suppose. Then again, we want to create a new uh, entry object over here. So we are saying that map dot put, what is the type of key? So we are saying the type of key is integer. So give some integer value. So we are giving 2 here, right? And then it is asking that what is value? So value is suppose 34. So this is suppose you can consider it as that this is roll number of the student and this is the marks that they have obtained. So something of that sort we are trying to keep here. Right, then again, we're saying that map dot put, this is a third value. So we are saying, suppose roll number is 3 this time and value is 45. So this is how we have, we have kept 3 entry objects inside this hash map. So when you use this put function, it is basically saying that this put function is going to put an entry object which it is creating with the help of this key and value, right? And then this created entry object will be kept inside this map, right? So this is what is happening at the moment. Now if we want to print this out, so you can simply
So,
use system.out.println. Yes.
yes, ma'am. I joined a little late. Can you explain what are you teaching today?
Today we are covering the concept of hash map. Okay, right?
STL,
Huh?
STL standard template library.
STL, no, no, not STL. We are covering hash map and hash table basics in any of the language and one hash map concept of Java. So collection framework. Today we are not going to cover STL.
मैम वो कल जो था उसका
Uh, were you able to solve those questions?
नो मैम टाइम नहीं मिला उसका जॉब है ना
So tomorrow you can do it, right? Because tomorrow your class is not going to be there. So you can do it tomorrow, and on Sunday also you people are going to have some time. So do it then, and on Monday you can tell me about all your doubts, right? Everybody, right? Right. First of all, let us understand this particular concept, right? So now, if you want to simply print these values, that is what is there inside this map, so you can simply pass on the reference of this map, which is map itself, and then all the key values will be printed over here. Right. Now, what is the benefit of this particular hash map? So if you want, then you can simply say that instead of having an integer as a mapped value, because it is asking that this hash map is saying that I want some sort of references over here, right? So it is simply saying that the key can be of any type and value can also be of any type. So there is no restriction in types, right? So it means that instead of integer, you could have one array list as well, right? So if you will have an array list, so that is also a reference type value. Reference type simply means that which you have to create an object of. So now we are saying that okay, the key is of type integer, but the value is of type array list, right? So what is the benefit of this? Benefit is that array list itself is a collection of different types of variables, right? So now we are saying that this is going to contain an integer. Now, if you want to suppose a store number of marks that the student has got, then you can simply say, let us first of all create an array list, right? So array list integer, and suppose this is related to the marks of a student 1, right? This array list is containing marks of a student 1, suppose. So we are saying that marks 1 dot add 10, right? So we have added one integer, and similarly you can add multiple integer values. So marks 1 marks 1 dot add suppose 20. So in the next exam, student number 1 has got 20. And then we are saying that marks 1 dot add, the student 1 has got maybe 56 marks in the last exam. And then you can map this particular key, that is roll number, with marks 1. So now if you'll get go and print these marks, you will get the updated values. That is how many marks he has gotten all the different exams. That kind of picturization you can get from here. Right? In the similar way, you can create another marks array list in which you're going to keep marks of a student 2, suppose. Right? So we are again creating marks 2. And now we are saying that suppose student 2 has got 30 marks in first exam, 50 marks in second exam, and 76 in third. And similarly, we are going to map roll number 2 with marks 2, right? So this time, 2 as a key is mapped to marks 2. And in the similar way, we'll have some sort of marks 3 array list, and that array list we want to map to. So this is our console.log. This is our print statement in which we are creating this marks 3 reference, right? And inside this reference, we are going to keep marks of student number 3, right? So something like that we have done, and we have mapped uh, 3 roll number with marks 3. So basically, it needs some sort of references, and then you can simply go and print this out. So now if we say that system.out.println map, so if we'll do this, then we'll get the values as this. So one is mapped to, okay, every time we are doing marks 1 dot adds, that's why this has happened. We'll say here that this is mark 2, in which these values has to go, right? And here all the values has to go inside this marks 3 array list. And now if you'll print these values out, then you will get some different answer. So one roll number 1 is mapped to 10, 20, 56. 2 is mapped to different values, and then 3 is also mapped to different values. So this is how hash map is working, right? So if you want to see this in picture, then what's happening here is that first of all, integer type of value is there, right? So whenever you write something of this sort, so let us consider this code and let's paste this code over here. So you're saying that we want to know that how this particular code is working actually. So it is saying that first of all, let's change the color of this code, right? And now we are saying that C, all right. So now we are saying that C, first of all, this hash map is going to create a container, right? An empty container. So this we have created. Afterward, this list, right? This list is going to be created somewhere else, right? And in this particular list, we have this 10, then 20, and then 56. Then another list will be created at some other place in which 30, 50, and 76 is kept. So this is basically marks 2, right? This is marks 1. And similarly, some marks 3 is also there, in which we are having 34, 51, and some other different value. Now, after creating these 3 type of references, what happens is that these lines are going to work, right? So this is suppose marks 1, right, in which we have kept 10, then 20, and then 56. Now map dot put 1 comma marks 1. What it is doing is that it is creating an entry object, right? So this entry object is created whose reference is kept inside the map. And in here, what's happening is that 1 is basically mapped with marks 1. So whatever reference of mark 1 or mark 1 is there, that is going to be kept inside this particular reference area. In the similar way, second entry object will be created, which is map 2. Here, we are going to keep the second roll number, that is 2. It is basically also a reference. So one object will be created in which 2 will be kept, and then the reference of 2 will be kept inside this 2, right? But for simplicity purpose, I'm writing the keys here itself. And then marks 2 will keep the reference of marks 2 object only. And in the similar way, we'll have some entry 3 here. in which 3 roll number will be kept, because here we were writing that map dot put 3 comma marks 3, and then marks 3 reference will be held here, right? So in the similar way, keys are also kept, like the references are kept, not the values, right? But just for simplicity purpose, we are writing here 1, 2, and 3. So this is how all the objects are basically being kept here, right? And the hashing basically takes O1 place, that is, or I could say that when you will try to access these values, so when you will say map.get map.get1, when you will say this thing, so it always take big O of one value. And the reason is that all these keys are basically hashed, and their hashed value is kept in a table, and then that table is used to get the address of the particular object. And that's how, just like how it happens with arrays, in the similar way, the hashed value is here used to get to that particular object. So that's why within big O of one time, you can go to any particular entry and you can retrieve the value. So that's why it is faster than any other data type, if you any other data structure, if you want to use. Right. So the accessing time of your hash map will be always, accessing time will be big O of 1, right? So that's why you want to use it, right? So this is basically access time when you know the key. When you don't know the key, then you always have to go through all the pairs, and you have to check that is this the correct entry or not. So this is how this complete process is happening. Now there are certain functions that we have to keep in mind, right? So is this much portion clear? Is this much portion clear? All right, let's move on. So now what happens is that suppose we are talking about this map, right? Now we want to see different functions that we can use over here. So the first function that we can use here is map.get, and in the get function, we'll have option to put the key over here, right? So you have to tell it, you have to tell the map that which particular key you have to get, and you have to pass that key over here. So whatever key you are going to pass, accordingly, some sort of object will appear, right? So now you know that all of these keys are basically having their values as a array list. So you can simply say that some array list is going to be returned back to us. So we are going to catch it inside this particular list, right? So this is how we have created one list object, which is going to contain integer type of, elements, and we're naming it as list. And now whatever list is there at this particular key 3 will be printed. So system.out.println, and we are saying that at this particular position, whatever answer is there, get us that particular list printed. So let us see that what is the answer at list at roll number 3. So it is saying at roll number 3, this particular list is attached. In the similar way, if you'll pass some different object, so if you will say that this time I want to look for key number 1, that is what is attached with key number 1. So marks 1, array list will be returned back, and that reference will be caught inside this list object, right? This list reference, and that's why 10, 20, and 56 are printed. So this is our get function. Right. In this similar way, we have some other functions as well. For example, if you want to find out, so this is done. Now we want to check for particular key. So there is basically a function which is called contains key. So suppose we are saying that system.out.println, we want to check that does this map contains a particular key, which is maybe any key you can pass. So we are saying that is this map contains this particular key, which is 2. So it is going to give us answers in the form of true and false. So if suppose it is giving us answer true, it simply means that this particular key is present. And if the answer is false, for example, if I'll pass 5 over here, so I want to know that is there any key which is 5 and the answer should come out as false. Right? So this is how with the help of a particular element as a key that you're passing to this function contains key, you can get the answer if that particular key exists or not. Right? So this is one of the functions that you're going to use very often. And then the next function that you use often in this particular map is get function. So you can simply say that map dot get, and in the get function you have to pass that which particular value you want to get, and this is how, so this we have used here as well, and the value, whatever value is there, that will be printed. So obviously we have used it. Another thing that you have to always you'll use a lot is put function. So that also you have seen. Then you have this contains value function as well. So you can pass the value and you can check that if this value is there inside the hash map or not. Right? So contains value is also a function which is going to return a Boolean answer as true and false. So it is very much similar to contains key function. Right? Then is empty function is there. Is empty basically checks that is this map empty or is containing any element. Then size function is there. Size function returns as the size of that map. Right? Then another important function that we want to use here is for traversal purpose. So if suppose any which ways we are going to learn this particular segment in detail also, but for now, for simplicity purpose, we'll see a very simple technique of traversal in which we want to use this for loop, and we are saying that we want to catch each of the so suppose let's create a simple map first of all, right? So here we are saying that we want a very simple map in which we are going to put some character values. So suppose A is a character and we have mapped it with 1. Then we are saying that we again have another function put in which we are passing B, and with B we want to pass some number 23, right? Obviously this is giving us error because here we have to mention, so integer is all right, but here we have to mention that this is of character type and the value is of integer type. So because of this array list, this error was showing, right? So these two we have corrected, and let's put one more value. So map dot put. This time we are saying that suppose the key is R and 45 is the value that we have passed to it. Now we want to traverse this complete map one by one, right? Traversal means visiting each element in a particular data structure. So we want to traverse each of these elements here. So now we are saying that suppose int I, we want to take out the element, right, from, so we are going to say that map dot, there is a function which is, which is, we have to find out what the function is. So it is going to return us all the values in the form of set. Right, so entry set, yes. So this is basically the function which is going to return us all the values in the form of all the key values, that is all the entry objects in the form of set. Right, so it is going to return a set of entry objects, right? So this is the function that we are using here, and then we are saying that return all the entry set because entry sets are being returned. So here we are saying that some entry object is going to be caught in the for each loop wherein the key is of type character and the values of type integer. Right, so this is how we have defined it, and then this error is coming because we have not imported it. So let's import it as well. Now everything is fine. So you have got your entry object in the form of ELE, and now you can extract one by one the keys and values from the element, right? So there is a function get key, which will get you the key of that particular element. And then there is another function which is get value. So you can use that as well. So you're saying that each time for all the entry objects get the value as well. So what's happening over here in this particular loop is, let's try to understand this as well before printing it. So in this particular example, what we have done is that this is our code, right? So this is our code, and in this code we are saying that suppose this is our, first of all, this is our hash map, and in this hash map there are three entry objects, right? So these are three entry objects. In first entry object we have a comma 1. In the second entry object we are having b comma 23, and in the third entry object we are having r comma 45, and these all are mapped with, or these all the reference of this particular map is contained inside map variable itself. Now what happens is that you're saying map dot entry set, so you're calling this entry set function on map, so it basically returns a set which is going to contain all these three objects, right? So it is going to contain the references of all these objects, right? And then one by one, all the references will be passed to this ELE reference type variable. So first time, suppose this variable is passed, right? So first entry object is passed to ELE when first iteration will begin, right? Because this is a for each loop, so it has to run three times because there are three elements inside this set. So the first reference is passed to ELE. Now it could be any of the any of the objects. So suppose a comma 1 is passed. So whichever element is there first in the set, that will be passed to ELE first. And then we are saying that this entry set, which is named as ELE right now, get its key. So in the key place, A will be returned, and then it is asking that what is the value. So here 1 will be returned, and those both the values are printed because system.out.println is written. Then this for each loop will say that, okay, one element is over. Now we want our second element. So now ELE will contain the link of the second object. That is, second object is suppose B comma 23. So the reference of B comma 23 is kept inside ELE at the second iteration. And then we are saying that get its key. So key is B, and then get its value, and value is 23. So these both will be printed. Then afterwards, ELE will get its last element, right? That is reference to the last element, which is suppose R comma 45. So wherever R comma 45 is there, its reference will be passed inside ELE, and again, its key and value will be printed. So this is how we are doing a very simple, iteration or traversal over this particular map. We are going to also understand about iterator, right? That how iterator works, and but we want to understand collection framework before that, so that's why we are not touching that part. So that's why we have seen a very simple for each loop for traversing these complete entry sets inside this hash map, right? So this is also one of the important topics that we need to understand before going in to solve the problems. Now we're going to begin with solving some of the problems. But before that, one more concept of hash table, which is very important, is suppose you want to basically, with the help of some sort of like arrays, if you want to make your hash table, so that is also possible. So let's say that there is a string S in which we are keeping A, B, C, B, 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 C, S, 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 R, 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 A, right? So suppose this is our string, and now we can do it with the help of a simple, user-defined hash table also, and with the help of hash map also. So now we want to create a user-defined hash table in which we want to keep the frequency of all the letters, right? So we want to keep frequency of all the letters that have come inside this string S. So how do we do that? So first of all, we are saying that, okay, we know that there are certain constants. So the constants are, let's say that there are going to be only small letters that are going to come inside this string S. Right? So the first constant is that only small letters, right, is only small letters are coming inside this S string, right? So this is first constant. So we're going to create this array of size 26. So integer new int and size is 26 because in our mind we are keeping this particular track that zero index is for A, then first index is for B, then second index is for C, and so on, so on, so on. 25th index is for Z. So this we have kept in mind, and having this in our mind, this is one of the reasons why we have created integer array of size 26. Now what we are saying is that do one thing, that create this loop, right? Which is going to iterate over this string. And one by one we'll see to it that which particular letter is it, and that letter will mark as +1 inside the array. Because initially everywhere in this 26 size array, all the letters will be zero initialized with 0 only, right? So we are going to do a simple plus plus, and at the end we'll get to know that, okay, what is the count of each of the letters. So we are starting this loop, and we are saying that int I equals to 0, I less than s dot length, and then I plus plus. So this is how we are going to traverse through the string. And first of all, let us take the character out. So we are saying s dot char at, and what is the index? So ith index, and then we are saying that arr, right? Arr, and simply we are going to do this ch minus a, because a is our base character, so we'll get the index. So suppose if the value of ch is c, so c minus a will give us 2, and at this particular index 2, so arr 2, we are going to say do a +1. So that's why a plus plus we will do. And this is how we have prepared the complete our frequency array. This ARR is our frequency array. So we have built this completely. Now, if you want to see that what is the count of each of the letters, then you can simply get it printed. So here we are saying that int I equals to 0, I less than 26. This time we are going to iterate through our frequency array. We are saying I plus plus, and whenever the count is not 0, that is if arri is not equals to 0, then get it printed. So system.out.println a plus I. So A plus I is basically going to give us a converted version of what this character is, right? Because index is right now representing the particular character. So we are saying that if you are at index number 2, so it is not actually 2, it is C. And how do we get to know that? So we are saying that the value of A is 97. Let's add some offset value into this A. So it will become 97 plus 2, that is 99, and then we want to convert it again to a character, right? So this is how we are doing this conversion. And after doing the conversion, we also want to print that what is this value, that is how many times has this A appeared, or has this B appeared, or has this C appeared. We want to print that as well. So we are saying that, okay, get this value printed as well, right? So this is how the whole thing is working. And now let us check. So we are printing it only for the values which are non-zeros. So let's get it printed. That is how many times each of the value has appeared. That count will come. So A has appeared 5 times, B has appeared 4 times, C 1 time, R 4 times, and S also 4 times. Right? In the similar way. So this is one of the ways in which you can solve this particular question. But if you want to do it with the help of hash map, so there is a technique for that as well, because we have just learned hash map as well. So let's create that as well. So we are saying at this time again we want to check the frequency only of each of the character, how many times it has appeared, and this time we are going to use a hash map. And this hash map is going to contain characters and integers. So character, because we want to know that which particular character are we talking about, an integer because we want to keep the frequency of that character. And then the name of the hash map is suppose map. And then let's create the object. So new hash map. And afterwards, we are saying that after creating this hash map, let's iterate over this string s. So we are saying that, okay, let's iterate over it. So int I is equals to 0, I less than s dot length, and I plus plus, right? And let's get this character out from the string. So we are saying that s dot char at I, let's get this character out. Once this character is out with us, then we want to check it inside the map. So now we are saying that if this map already contains a particular key, right? So we are saying that if this map contains the ch, then you have to add to the previous value. So map dot put, right? Or map dot put if absent also you can use, right? And compute if present you can use. So these two function can also be used, right? I'm using here the put function because any which ways, if there is a key with the same name already existing, then it is going to change the value, right? So we are saying that if map already contains this particular key, then we are going to put the ch again, but this time with an updated value. So map dot get the previous value of the ch and then add +1 into it. But if this is not the case, then simply put it with 1. That is, if this character is coming for the first time, it is not present in the map already, then put this new value inside the map with frequency count as 1. So this is how we have completed our hash map, and afterwards we want to get it printed. So you people already know your for each loop, and inside your for each loop you always say that okay, we are going to get our entry object out, right? And then this entry object is going to contain one character and one integer value, and then let's name it as ele. And here we are saying that this ele is coming back from map dot entry set, right? So because it is going to return a map dot entry set is going to return as a set, and one by one we are going to get the values out into ele, and then we'll simply say that okay, let's print these values. So ele, right? So or otherwise we basically just want to print these values, so we can simply do a system.out.println as well, because we don't want to do any kind of computation right now. So we don't need this for each loop as well. So simply printing the map and getting the values, that is whatever is there inside the map. So the final answer will be same, which is this. So A is 5, B is 4, R is 4, C is 1, and S is 4. These are the final values that we have got, which are very much similar to the previous case. So this is how we have used a string, and we have computed that how many times each of the character has appeared, right? Now the next question could be that can you tell us that which particular, character has appeared the most number of times, right? So some this kind of question can also come. So now you will need that for each loop. Now this map printing will not work. Now you will say that okay, get this entry object out from the map and then check that what is the maximum value. So now we need a max also, right? So current max we are going to initialize with the integer dot min value, right? Because initially we are thinking that okay, this, or otherwise you can start with 0 as well, because frequency count cannot be in negative. So integer dot min value, you're going to start from here, and then you're going to check that if the current frequency count, that is, if element dot get value is greater than the current maximum, then update the maximum. So maximum is equals to element dot get value. Maximum is equals to element dot get value, and you can also keep this particular maximum element track as well. So how you can do that is you can simply say that okay, this max ele also we want to keep a track of, right? And that's why we have created this entry object, and whenever you're updating your max value, at that moment you have to update your max CLE reference as well, and you have to give it this element reference, right? And at the end, when you will check that what is this maximum element, so let's print these all numbers as well, and then let's check that which is the maximum element as well. So both of these you want to get printed, right? So have not been initialized. So let's initialize it to null, right? So now we want to see that what is this maximum pair that has appeared in the map. So it is saying that A9 is your maximum value. So this is also one of the use case of this particular hash map. So I think that this is also clear. If there is any kind of doubt, you people can ask. Otherwise, we'll go on with the next topic. But hopefully this is clear. All right, so there are few questions also that we have to do, right? That is to some contains duplicate, etc., etc. So I have told you like two ways in which you can go for this implementation of hash table and hash map. And now we'll simply start implementing these lead code questions as well, right? But before that, I just want you people to go through this complete video. And in the next session, we are definitely we are going to cover these questions, right? So to some contains duplicate. These are some of the questions whose edge cases we have to understand because they are very frequently asked in a lot of questions, in a lot of interviews, right? So the first thing is that you have to watch this video. You have to understand that what this hashing technique is, and then we can simply go for solving the lead code questions. I'll end today's session over here itself, but then in the next session we are going to see to these particular concepts as well. All right, guys. So I'll meet you in the next session. For today, we are going to wind up the session a little bit early, right? All right. So take care. Bye bye, and let's meet in the next session.